So chapter 3, we are going to discuss about motion in a straight line, where some books refer to this chapter as motion in one dimension as well. So we call it as motion in a straight line, or you also call it as motion in one dimension, right? So I think most of you would have known with this chapter. You have already learned it. Can you tell me at which grade? In which grade did you learn this? In your 9th grade, you would have already learned this, right? And with the same name, motion in a straight line. But here we call it as motion in one dimension. Either of them is excellent. I wrote this name because you'll be able to relate it to your 9th standard. Okay. So that is one thing. And just for me to have an understanding, what do you think we are going to study in this chapter? What is your perspective or what is your idea about what we are going to learn in this chapter? Can you tell me? They don't look at the textbook. You tell me on your own. Name itself is suggesting. No? Try to always dissect it and understand. So first basic thing is we should understand what is the difference between motion and the counterpart of it. That's what the name is. No, the first name that I'm able to see is motion. So what is the counterpart of it? Obviously, rest. So that's what we are going to understand. Secondly, when you talk about a motion, it is going to have a change in position taking place, right? So how the change in position is going to take place is basically classified into two types. I can say it is three types also. If the motion is confined only to one direction, you call it as motion in a straight line. If it is confined to two dimension, you will call it as motion in a plane. Yeah, motion in two dimension, or you call it as motion in a plane, which is going to be the next chapter. And if it is going to be confined to three dimension, you're going to say motion in three dimension or motion in space. Okay. So one dimension is called as line, two dimension is called as plane, and three dimension is called as space. Okay. So now we'll confine ourselves only to line. Okay. If that is a scenario, then it is always important for us to start understanding the terminologies in the chapter. When I say terminologies, the terms that we are going to use. So basically, I would say you have heard the word nomenclature, like in your organic chemistry, something like that. We can say nomenclature of this chapter. What are all the terms that we are going to use so that we'll be able to understand it in the future, right? So first thing I would like to understand is what is rest. So let's have a discussion. So when I say rest, what comes to your mind? Like, how do you define it? So what was happening? I was moving here and there, no? When this was happening, there was a change in position, right? So whenever we are going to see an object, we need a reference point. If I suppose I take this end to be the reference point, right? So I start from here. If I'm standing here for, let's say, 5 minutes, what will you say my state of motion is? I am at rest, obviously. So how you put it in a definition? When there is no change in position of an object. So when I say, yes, change in position, when I use the word position, I'm trying to speak with respect to a reference point. So what is the reference point? With respect to this point, I'm always at rest. Right? My position is not changing. So to put it simple, an object is said to be at rest. Right? Under what scenario? When there is no change in position. But my question is, you're talking about change in position with respect to what? With respect to a reference point, and most importantly, with respect to time. So what will you do? When I'm standing here, you know what is the reference point. But when will you say that I'm at rest? If I put this question after 5 minutes, you'll do an analysis and tell me, no? So you'll say, sir, for the past 5 minutes, you were at rest. Right? So when there is no change in position, WRT is with respect to what? With respect to time. Second. Obviously, what is going to be the counterpart of motion? So when I talk about motion, what will you write? an object is said to be in motion when there is obviously what? There is a, yes, change in position with respect to time. So this is what motion is all about. When I classify this motion, right? You know what is the meaning of classification, right? What are you doing? Drawing something like this. It's basically divided, right? Whenever you do a classification, what is the most important point on which we need to concentrate? We need to understand the classification is done on which basis. So the classification should be done on some basis. Here the basis is, okay, here the basis is going to be the direction. The direction in which the object is moving. So if it is moving in a straight line, you call it as one dimension. If it is moving in a plane, you call it as two dimension. If it is moving in a space, you call it as three dimension. But here our topic of discussion is confined only to the direction. Are you able to understand? I keep it here. It is at with respect to time. Like if I hold it for some time also, right? If I'm moving it like this, can you say that this object is moving? Now here comes an important question. When I move it like this, who is moving? Is my hand moving or is the object moving? Hand is moving. But relatively, what is happening? Object is also moving. But the object, is it possible for this to move on its own? No, right? So what is needed for it? Force. So you need a force. So why he used the correct word? You need external force. Why do we say external force is needed? Why not internal force? What do you mean by internal forces? So is there any internal force existing in it? There is no battery. Then there is no internal force. Maybe yes. Think in terms of chemistry. What is this material made up of? Anything this world is made up of? Okay, plastic. Plastic also is made up of atoms. So atoms consist of charged particles. So those charged particles can always exert force on each other. They can either attract or repel. So based on that, there will be some internal force present in it, but that is not able to do any work on this. So for you to move an object, what is needed is external force, right? So when I say external force, can I classify it like this? I'm concentrating on two things. I'm interested in understanding the motion of an object, and the second thing I'm talking about is force, which is the external force. Am I right? So one should be the cause, one should be the effect. Effect is the output that is coming out. So among these two, which is the cause, which is the effect? Force is the cause and motion is the effect. So there is a reason why I was stressing on this point. Listen to this carefully. When we discuss about motion in one dimension and motion in two dimension, when you're describing the motion of an object, there are two ways in which you can analyze it. One is, if you are concerned about the motion of the object plus the cause, you call that branch of physics as dynamics. Am I clear with this? So what you're doing is you're basically studying the motion of an object, but parallelly, what are you trying to understand? Who made that object move? That is a cause. If you're studying about both these things simultaneously, you call that branch of physics as dynamics. Then what is the other branch? That's what we need to understand. So I'm only concerned about motion, but I'm not concerned about the cause. This branch is called as kinematics. So this chapter and the subsequent chapter, we are going to study motion, but not the cause. Right? That is why the name of the chapters are motion in one dimension and motion in two dimension. Whereas you can ask me what chapters fall under dynamic. This is also a concept that you have already learned, which is the laws of motion. Here also you see the word motion. But what is that you study in laws of motion? You are concerned about force. All the three laws speak about force only, no? So force is a cause. Are you able to understand? So this is another important thing you need to understand.